Hello, and thank you very much for joining us to view this webinar. If you just be patient for a couple of moments, we've got a few more people joining, so I'll just give it another minute or so for them to join and then we'll get started. Thank you. Okay, all right then, let's get started. So thank you again for joining us. I'd like to welcome you to the Taylor Hobson Optics Department or Metrology Department webinars. Today I'd like to introduce you to Dr. Yang Yu. She's our Senior Application Scientist and she's been working at Taylor Hobson for 15 years. She's really specialised in optics metrology, working with the contact and the non-contact instruments. As I said, she's got a wealth of knowledge on this. In this webinar, Dr. Yang Yu will be going over advanced metrology of freeform surfaces. So I think you'll find this quite an interesting one. Obviously, freeforms are a very important part of optics development at the moment. What I would like to say is that if you do have any questions, please log them in the Q and answer section, and we'll do our best to answer them at the end. So if you'll just bear with me, I'll just transfer Yang over to you. So if you just, okay.
Hello, everybody. Thank you for joining the webinar. My name is Yang Yu. I worked in Taylor Hobson as introduced by Neil, nearly 15 years, mainly focused on the applications of optical instruments. For example, it's white light interferometer, CCI, non-contact Luphoscan and PGI Freeform. Today, I'm going to introduce the advanced measurement techniques of freeform surface. In this talk, I introduce the freeform surface and talking about disadvantages of conventional measurement techniques, and introduce Taylor Hobson's measurement technique, mainly talk about PGI Freeform. There are many freeform applications. Most of them are in optical field. For example, head-up display lens, camera lens, and fiber optics, small freeform in telecommunications, optical mirrors, contact lens, and other fields like car bodies, turbine blades in aerospace, and hip joints in medical field, and some others. Why in the optical system employ the freeform optics? Nowadays, the optical system are getting smaller and more compact, and lighter and high resolution is needed. The traditional spherical lens and aspherical lens cannot meet the requirements for some optical systems. Employ the freeform optics can still keep the original performance or even better performance. For spherical and aspherical lens, there are some limitations sometimes, such as a spherical shape cannot produce certain light beam path. It does need a more complex freeform surface. For the freeform surface, there are many types. Can be rotational asymmetric, can be rotational symmetric. From the surface is from small down to millimeter up to large, more than 1 meter. From shallow to steep, from low reflection to high reflection. There are many different materials are employed. And also there's one single freeform lens. You can see the various freeforms in different regions and freeform micro lens array. If you want to inspect freeform optics, you have to compare with its reference surface to calculate the surface form error. For the surface design, there are different types. Some of them can be described by mathematical equations. Some of them can be described by cloud points or seg table STL file. For the equations, there are many types. For example, aspheric optics of axis aspheric optics and polynomial design, toric design, asymmetric lens, ellipsoid, biconic design. For the freeform measurement techniques, because the freeform is often complex shape, most of them are asymmetric. It's difficult to measure. If you use conventional contact techniques, most of them are 2D measurements. Even you have a wide stage, you can manage to get 3D data, but the range is not enough, gauge range, and also can be difficult to set up because the alignment is critical to get to measure the form error. It often needs the causative fixture. After you tried everything, still the accuracy is not enough. Also, because it is contact, there is stylus force. It could make scratches on some materials. For the non-contact techniques, such as white light interferometer, there is a slope limitation. For example, for the lower object length, like 5 times, only can measure a few degrees of slope. Even for the higher object length, like 50 times or 100 times, maximum only can measure the slope up to more than 30 degrees. But the field of view is so small. For the 100 times length, it's only 0.1 millimeter. So you can imagine if you want to measure even a few millimeter diameter optic, it takes ages. And the working distance for the higher object length is so small, the operator wouldn't feel comfortable, and the measurement range is very tiny. So none of the conventional contact technique and the conventional non-contact techniques is good enough for the freeform measurement. So the ideal freeform metrology should be easy to do the setup and the alignment, and functional, flexible, can measure the large slope surface. Also, the gauge range should be large enough to detect all the surface features. High resolution, and also high resolution and accurate and repeatable. Measurement fast, and ideally should be fully automatic, and the cost should be low. Hobson Hobson has two different freeform measurement techniques. One is PGI Freeform, another one is non-contact Luphoscan. These two instruments' principle is different. In this talk, I mainly introduce the PGI Freeform. It is an advanced 3D contact technique for freeform measurement. PGI Freeform is developed based on the PGI gauge. The PGI means phase shifting interferometry. It has many benefits. It overcomes the shortcomings of inductive gauge. For example, the inductive gauge has very small gauge range, and also its resolution is dependent on the gauge range. For the PGI, it has extremely high accuracy and good linearity. Also, it has a much larger gauge range. Typically is 12.5 millimeter, and the resolution is very high, down to sub-nanometer. And the very important benefit of PGI gauge is its resolution is independent of the gauge range. PGI Freeform, here is the PGI Freeform. It employs the PGI gauge. Also, it has a precise rotary stage with an accuracy of 4 arcseconds. And very important one is it has a low noise air-bearing Y stage with an accuracy sub-micrometer over 200 millimeter. Its measurement volume in the size in XY can measure up to 200 millimeter by 200 millimeter for the standard PGI freeform. For the other PGI, like a PGI plus a Y stage, can be up to 300 millimeter in X direction. Vertical. For the vertical range, there is a 190 millimeter can be used. It has a very large gauge range. For the standard stylus, can be up to 14 millimeter. You can get an increased gauge range with using a longer stylus. For example, if you use 120 millimeter length of stylus, you can get a 28 millimeter gauge range. And it's a very important benefit for the PGI freeform. It can measure the very large slope in X direction. In X direction, it can measure more than 50 degrees. In Y direction, can be up to 35 degrees and still keep the good accuracy. But you still can measure more than 35 degrees. Just the accuracy is not seem good. So for the PGI freeform, it has a large gauge range, has a high resolution, and high precision and low noise rotary and Y stage. Also, apart from this, Hobson developed special algorithms in order to remove all the possible errors to get the most accurate results. For example, the raster scan calibration and other corrections like Y twist correction, Y gun correction. And also after a lot of efforts for the development of software, the measurement software now is very intelligent and powerful. PGI freeform not only can measure the form error, it also can measure roughness and dimensions. For the form measurement, it can measure all the types of optics, such as spheres, S-spheres, diffractive Fresnel lens, and all the type of freeform surfaces. In addition, PGI freeform also can measure the multiple paths, like the microlens array. Any types of freeform surface can be measured within the measurement range if no stylus flanking. No matter what type of the design of your surface, like the mathematical equation design, cloud point, or seg table design, or CAD model design. In order to get the best accuracy, Hobson developed a special algorithm, raster scan calibration. It is performed by using a traceable ball standard to do the series of 2D scans, get a 3D surface cloud point, establish the constants, use the constants to remove all the possible errors from mechanical alignments, like the stylus pivot angle from the stylus plane alignment, from y-axis gain error, and the perpendicularity of x to y. And also for the twist calibration, twist corrections is also Hobson developed, and Hobson patent is y-gain correction. For the freeform surface measurements, you can get a 3D surface cloud point by number of 2D raster scan data, and then applying all the calibration data and correction data to the surface data. After that, use the freeform analysis utility to calculate the surface form error. Freeform analysis utility FFAU, it is an intelligent and very flexible software. The imported 3D cloud point surface can be aligned in the software in order to get the same orientation as the reference surface. So if you want to calculate the form error, in theory, the orientation of the surface data should be same as a reference. And this utility, the big advantage is it can control quite large degrees of freedom during the fitting process. Therefore, the alignment doesn't have to be so critical. For example, even you have a few degrees twist error from the reference surface, it still can calculate the surface form error accurately. And this software can accept all the different types of surface design, like equation design, STL design, seg table design. And it can also manage the analysis of optics without full surface design information. This is also the benefit of this software. Sometimes the surface design only part of the information, but this software still can work out with applying its special algorithm. Apart from the surface form error analysis, this utility also has other features. For example, STL file can be saved from the 3D surface data. The measured cloud point surface can then be fed back to the graphic software, which is useful for the optical designer. Also, other analysis is possible using Hobson's another software, Talymap, such as zonic analysis, profile extraction, and calculate dimensions. PGI Freeform measurement software now is really intelligent, easy to use. No matter what type of your reference surface, it also always can define the surface in the measurement software directly. For example, equation design or the CAD model or the cloud points. For the equation design, the user can directly type in the design data into the software interface. So it's very easy, no need to have any programming skill. For the CAD model or the cloud point XYZ design, you can directly load in the design data in the software. You can align the surface if the orientation is different from the surface, the sample surface on the stage. You can use the software tool to align the surface and then to be ready for the measurement. Here is an example of the freeform measurement. I show you a video. It is a cylindrical lens. It's fully automatic for the alignment and measurements analysis. And you can see the stylus move to the first reference mark, cresting, remember the position, and then moves to the second one, alignment. After that, start to do the 2D scans. It knows where to go, where to start, and how much lens should scan at any position. So it is really intelligent. It makes the complex freeforms measurements is very easy for the user. And it's automatic alignment, automatic measurements, automatic save all the data in the user selected folder. And also at the end, it directly shows the 3D surface form error in the measurement software with a parameter such as PV. For the PGI Freeform, not only can measure the single freeform optic, also can measure the batch freeform. Here is an example. Again, also is fully automatic. You can see the stylus is the same. First, doing the alignment, second reference mark, and then going to the user select lens, measure the surface by following the surface design. So after measure all the user select lens, and then the analysis can be done automatically and automatically save all the results and all the related data in the selected folder. You can see this measurement measured 5 lenses. If you want to view any results for any lens, you just click the image of the lens image. You can view the 3D surface data, also can view the surface form error. You also can check the individual lens data at any time after measurements in the measurement software. Another technique is Hobson's is non-contact Luphoscan. This should be introduced in more details in another webinar. But here, just to show you a video. This is different from PGI Freeform. It doesn't do the raster scan, but it does the spiral scan while the sample rotates on the stage. You can see the probe move down to scan the surface. You can see move up to the up and down. It's trying to follow the surface design. This is an off-axis parabolic freeform. At the end, it automatically shows the surface form error. This technique has a slope limitation, cannot measure very strong freeform, but it can measure very large optics up to 850 mm diameter optic. For this non-contact freeform technique, after continuous software development, now it makes most of freeform surfaces can be easily measured. For example, in the measurement software, you can for the toric or biconic freeform, you can directly type in the design data in the software interface. Its measurement is the same easy as doing the aspheric measurements. Or for other freeform optics, the Hobson developed a software tool. You don't need to do the programming. You can just type in the design data of your reference surface into the software tool. The software tool can generate a Luphos required stack table. After that, measurement is very easy. We appreciate Hobson has the best non-contact Luphos scan for the freeform technique, freeform measurement technique, and also the best contact freeform measurement technique. So its correlation gives us a confidence for the technique. Example here is a toric freeform optic. You can see this is the results from the PGI Freeform. This is results from the Luphos scan. You can see all the surface features are detected, looks like twins, very similar. So very good correlations. Another one is quite a big freeform optic head-up display. It's 150 millimeter by 50 millimeter size. This is Luphos scan results. This is PGI Freeform results. Again, it's also very good correlations. Actually, we've done many correlations, but here is just a couple of examples. In summary, PGI Freeform has very good resolution, gauge, and very large gauge range, and it can measure very large slope, more than 50 degrees in X, so it makes it possible to measure almost all the freeform surfaces. It is a real freeform metrology tool, flexible and powerful. Not only can measure the form, also can measure roughness and dimensions, and also it can measure the multiple parts. Both PGI Freeform and Luphos scan can measure any types of freeform surface within the measurement range. Luphos scan is different, but is capable of measuring very large optics. So thank you for listening. If you have any questions, quick questions, we try to answer now, or if you all can contact with us by email. This is my email address, and this is our product manager near Fitzgibbon's email. Thank you again.
Okay, thank you very much, Yang. That was a very interesting presentation covering some of our interesting applications that we have and the way that we can measure freeform surfaces. As Yang said, if any of you guys listening have got any questions, feel free to contact us on the email addresses on the screen at the moment. Alternatively, you can go to Taylor Hobson and go to your local applications engineers or sales engineers who should be able to direct you in the right direction for the answers if they can't answer them themselves. We are running a series of the webinars, so I think we have our next webinar in 2 weeks, and that will be focusing on the Luphoscan and setting up parts and measurement techniques on there. So you'll please join us for that. Otherwise, it just leaves me to say thank you to Yang again, and hopefully we'll be talking to you again soon. Thank you very much. Bye.